Okay. Good afternoon, everybody, and welcome to our FCS Express version 7 seminar that we're hosting in the flow cytometry core facility at MSKCC. My name is Kathy Daniels, and I'm the manager of the facility at Memorial Sloan Kettering Cancer Center. And we're very grateful that we're joined today with Sean Burke, who's agreed to do these seminars for us. He works at DeNovo Software, and he's going to be giving the bulk of the classroom today. There are just a couple of slides that we wanted to review before we got started, though. So we're going to get going. And we hope everyone's staying safe and healthy at home, most importantly. So for today, as many of you are aware, we're going to be discussing compensation and unmixing in FCS Express 7. We're going to be talking about the importance of single color controls and why they matter as we're looking at this. And this is important no matter what software that you're utilizing. So it doesn't matter acquisition analysis, software, these practices are going to apply across the board. So keep that in mind as we have these discussions today. And then we're going to be talking about the rules of compensation and unmixing. Okay. Some important links that we just wanted to go over briefly. DeNovo Software. So DeNovo puts out FCS Express 7. So if you have any questions, if you go to DeNovo Software, that's where you'll be able to go ahead and get FCS Express 7. There's a lot of information there. So feel free to go ahead there and take a look at their website. Then we also have FCCF's website, which is fccf.mskcc.org. We have recordings of previous sessions. So last week, Sean did an introduction to FCS Express 7 for us. So we have that recorded there, in addition to any of the educational content, SOPs, and all of that and important information. As these are educational opportunities and webinars are rolling out, or any important announcements we've been announcing them on our Twitter, and our handle is @FlowMSKCC. So feel free to visit us there. For anyone that's interested in the field of flow cytometry and might not have kind of gone into it too deeply so far, the ISAC website is a really nice tool to be able to get information for flow cytometrists. And they've had a wonderful initiative to open up Cyto University for free while most people are working from home, given the current scenario. So we thank ISAC for that, and feel free to visit the Cyto University page. For anyone who's looking to do some flow cytometry analysis but might not have any data on hand, but they still want to get the practice as they're working from home, please feel free to visit flowrepository.org and get some FCS files that you can play around with. Okay, then there's also the Cytometry Part A journal, which is a really nice resource for cytometrists. That's the long link there to discuss or to take a look at that. Then we have the MetroFlow website. That's our local New York, New Jersey users group meeting. So we have it twice a year. We have a meeting in the fall, and then we also have a vendor meeting that's typically in the spring. We're pushing our vendor meeting in the spring actually out to July, but all that information can be found on metroflow.org. And then lastly, we have a YouTube link there to reference how to turn text or images into FCS files, which we thought was kind of cool, from David Gravano. All right, so I accidentally made this slide twice, so you're going to see it twice. I'll correct that before we send it out to everyone today. But some important context for FCS Express 7 is Sean Burke, rather, and that's sean.burke@denovosoftware.com. Then there's Rui Gardner and myself at mskcc.org. So feel free to reach out to any one of us with questions, and we'll do our absolute best to get anything resolved for you. Okay, and Rui is the head of the facility at Memorial Sloan Kettering. Okay, again, I listed it twice. So now what we're going to do is we're going to talk about very briefly some important rules of compensation and what you want to look out for before Sean dives in. So the first rule of compensation that I'm going to discuss with you is that we need to use the same exact fluorochrome that's in your experimental samples. Okay, why, right? Why does that matter? Why can't I just use BV421, for example, as you're seeing here, as opposed to DAPI? What I wanted to do is explain to you why all fluorochromes are not created equally. Oftentimes we have people that are coming to us where they might say, okay, it's in the same channel, right? It's PAC blue and it's BB421 and it's DAPI. I can read them all off the same channel. It's excited by the violet and it emits around 450 nanometers. So why can't I just use one color in replacement of the other? The reason for that is there's going to be differences in the excitation and emission, and what winds up happening is the spectral fingerprint of all of those fluorochromes are going to be unique to themselves. So DAPI and BB421 is a nice example of that. And what you can see here on the bottom where I'm hovering my mouse is that we have an excitation or a similar excitation and emission of DAPI and BB421, but this DAPI actually, it also peaks in the UV in addition to the violet. So you see this like pink line, and that's showing the DAPI. And you also have BB421, and they do have a similar point of emission off of the violet. But so while you'll be able to detect both of those off of the same channels on a conventional cytometer, and while you'll see them somewhat similar on spectral if you're looking at specific channels, the spectrum is completely different and it gives us a different spectral fingerprint, okay? So we can't use them to replace each other. A nice example of that is a data set where I had a user that had brought in a BV421 single color, and then once we started looking at her data, I said, this doesn't look like a CD marker, and she said, oh, well, it's DAPI. So when we looked at the BV421 as the single color and compensated with that, if you see looking at it with FCC and BV421, there's a clear overcompensation. And you can see that because it's swooping, right? We're seeing that it looks incorrect by eye. So we have that nice visual pattern that's showing us that the compensation does not look correct for this experimental sample. So what we did, luckily, is we had a viability alone, and we recalculated that compensation using the correct fluorochrome that's actually in the experiment. And what you see here is once we do that, the MFI of the negative and the positive populations are now in line with each other, and we're not seeing the swooping one way or the other as much as you saw it here on the BV421. Okay, DAPI is a little bit of a tricky example of that sometimes because dead cells can non-discriminately bind to your antibody. So it can be a little bit of a tricky example, but here it worked out really nice. We were able to see how clearly overcompensated it was with the incorrect fluorochrome. Our next rule of compensation is that the negative and the positive populations must have the same autofluorescence. What do I mean by that? I don't have a visual here, but what's going to wind up happening is all autofluorescence is not created equally. So many times what's going to happen is you're going to use beads for your single colors, but there might be one or two samples that you have to use cells. Cells and beads are never going to have the same autofluorescence. Different types of cells will have different autofluorescence. Different types of beads will have different autofluorescence. So what you always want to do is you always want to take that into account and make sure that when you're gating for your negative and positive and referencing those, referencing the negative and positive for single colors, that you're accurately accounting for the autofluorescence of the particle type that you're working with, okay? So that's very critical, and you'll see that discussion often on Purdue where someone's wondering, why is my compensation not looking right? You know, I have single color beads and cells, but I use the universal negative, right? So that's something that we want to steer clear from. Never use a universal negative when you have a mixture of different particle types for compensation, okay? Our third rule of compensation is that the signal in the control must be as bright or brighter than observed in the highest expressing sample. Why is that? Okay. A correction of spillover requires the brightest expressing signals that the algorithms that we're utilizing can do their jobs correctly. If the MFI of the single color is not as bright as it is in the experimental sample, you're going to wind up with incorrect compensation. So what we recommend in the FCCF at MSKCC is the first time you're running your experiment, the first time you're testing out a panel, you should always try running the beads and the cells single color to make sure that you can calculate correctly that first time, and then on subsequent runs you should have a good idea of which ones will result in the appropriate compensation or unmixing. Okay. And a nice example of that is right here, where a user unfortunately did not bring the most or the best single color controls. And if I'm looking at the AmCyan versus the APC size 7, what are we seeing? We're seeing again the population is very clearly dipping off and showing overcompensation, and this was the result of an incorrect single color control. So these are all things that you want to be very mindful of, and you'll see that you might not think it is that important, but once you start seeing the data and seeing incorrect compensation or unmixing, you're going to be tempted to say, okay, something happened with the instrument or this and that. And the first thing that we want you to actually do is go back and look at those controls and make sure you're looking at all of these rules of compensation and do like a mental check. Is the correct negative and positive reference for my particle type? Okay, is the signal as bright or brighter than observed in that highest expressing sample? And did I use the correct fluorochrome? So I want you to always think of those things. And if you have any questions, you could always reach out. And that being said, I'm going to pass it along to Sean. And I just, before I completely pass over to Sean, what I want to do is remind everyone that throughout the duration of this talk, if you have any questions, please feel free to utilize the chat function that's in the Zoom meeting. And what I'll do is I'll monitor those questions, and at the appropriate time, I can chime in and ask Sean to make any clarifications if I feel that it's not appropriate to answer in the chat box myself. So please feel free to ask some of those questions. And with that, I'm going to stop sharing my screen. I'm going to let Sean take over.
Great. Thanks, Kathy. And you can hear me here, right?
Yep.
And you can see the screen coming through?
Yes.
Perfect.
And I will take off my video.
Great. And yeah, again, thanks everybody for joining us today. I think the rules that Kathy laid out there were some really great ones, and something that can be applied to every lab who's doing any sort of analysis. I'd make kind of one additional rule as an add-on to that, and kind of in addition to the last rule, is never perform compensation by eye, right? I know it's very tempting to kind of use slider bars and move things around the plots. But as Kathy mentioned, if you have the correct controls, you followed the first 3 rules, you should never have to perform compensation by eye. It's kind of a big no-no. So, kind of keep that in mind. And what we're going to talk about today from an FCS Express perspective is how to implement compensation, and how to implement something new to FCS Express, which is spectral unmixing. Spectral unmixing just came out in the software actually just last week, so it's something new and kind of exciting for us, and I think a lot of people in the flow community to be able to do unmixing directly in FCS Express. And again, we're going to give you a kind of practical overview, right? How to create compensations, how to create unmixings. You can kind of see here in our agenda today, we're first...
Sean, just really quickly, I don't think the screen is sharing just yet.
Oh, let's see.
So you should be able to. Let's just make sure. And I'll let you know once it pops up.
All right, let's see here.
Thank you, everybody, for your patience. This is multiple.
It's all right. You got it coming through here?
Yes, now we're good. Thank you, Sean.
All right, great. All right, so you missed my my first most exciting slide with my name up there, but you all know my name already, so that's fine, and we'll just kind of skip over that. But again, what we're going to kind of talk about today is how you bring in compensations to FCS Express, how you bring in unmixings, whether it be from a mixing or compensations that are from the time of acquisition, or things that we do after the fact in our analysis software, in this case FCS Express. So we're going to show you how to bring those in. We're going to show you how to set set up an automatic compensation. We're going to show you how to set up an automatic unmixing, and then we're going to show you how to get that applied over to data files. So I know with the unmixing section, unmixing in FCS Express is new to a lot of people. I want you to keep in mind we're going to kind of cover that at a high level today and talk about the practicalities of implementing unmixing in FCS Express. However, if you do want to get a detailed kind of overview of unmixing, both the theory of unmixing and really all the nitty gritty about how to do it in FCS Express, I do recommend you go to our website. We're going to have a webinar in just a few weeks, and you can click towards the bottom of the page here for upcoming live webinars. And on the 29th, we're going to do a full, hour-long overview, how to perform spectral unmixing. We're going to talk about really all of the ins and outs associated with it. But again, coming over to our agenda today, we're going to first kind of go in and take a look at compensation, and then we're going to take a look at unmixing, and we're going to talk about that all with some real data in the context of the software. So with that, I'm going to kind of get my PowerPoint presentation out of the way, and I'm going to open up FCS Express, and you can see FCS Express is open here, and I know, again, this kind of looks like PowerPoint. It's kind of shamelessly by design set up to do so. And the first thing I want to point out with compensation is that if you're doing compensation at the time of acquisition, when you bring data files into FCS Express, by default, they will be compensated. So this is the kind of lowest hanging fruit. You've done compensation at the time of acquisition. If I drag this data file into FCS Express, I choose to put in, say, a density plot for this. I'll leave it ungated, but let's look at CD4 versus CD8. What you're going to see, right? This data kind of looks nicely compensated. There's some beads in here, which is why you see this down here. But it also says in the title that this data file was compensated. So again, the default in FCS Express and the way that we handle loading compensations and unmixing from data files is through our preferences. So if we click on the File tab and we click on Options, what you're going to find is at the top of our options screen, really one of the first things you're going to see is the compensation to use. And what we do in FCS Express is if there's a compensation associated with the FCS file, we use that first. We always assume that's the compensation that you want to use, and that's something that was done at the time of acquisition. And then if we don't find anything from acquisition, we use something called the compensation default, which I'm going to come back and talk about in just a little bit. But we can also do the inverse. So if you're not doing compensation at the time of acquisition and you're always doing it after the fact in FCS Express, what we recommend is you come in and you change this to the compensation default and then the FCS file. And what that will do is if you're used to working with post-acquisition compensation, we're going to know that from now on. So anytime you load up a data file, we're going to look for some sort of compensation default, something that you set up in FCS Express. We're going to apply that to your data file or any data files that you're loading. And then we're going to, if we don't find that, then we'll use that compensation from the time of acquisition. And the same kind of thing it's similar with unmixing. It's a little bit different, just the way that the data files and structures are set up. So in this case, this was a kind of standard FCS file. If we want to look at some unmixed data, coming from the SpectraFlow software or from the Aurora, just so you're aware, when you export that data, you end up with a file, two folders. One of them is called raw, and this contains your data sets that are raw from the cytometer. No unmixing matrix has been set up or applied to these. And then you end up with a data folder for something called unmixed. And all of your unmixed data, any data that was unmixed, say in SpectraFlow software, it's going to be accessible to you here. So if you want to pull in your unmixed data sets and use the unmixing from SpectraFlow, simply drag and drop a data file into FCS Express, one from the unmixed folder. FCS Express is going to prompt you to insert a data file for that or some sort of plot. And again, you can get off and running with the data and you can see that it looks like it's been correctly unmixed. So, with unmixing, if you want to use unmixing from the time of acquisition, or from SpectraFlow software, grab the data files from the unmixed folder. And what we're going to do in a little bit is actually unmix this data ourselves in FCS Express using everything from the raw folder. All right. So let's kind of come back to FCS Express and let's talk about how we create a compensation. And what I'll do is I'll just remove a few of these plots, and I'm going to open up my data tab here to get rid of some of the things that loaded there automatically. But essentially in FCS Express, all of our compensation and unmixing is done within our tools tab and this little button here for compensation and unmixing. So if we click on this, it's going to launch up a little dialog. And in this dialog box, it's going to show you if I had a data file loaded in the software, it's going to show me the matrix associated with that. So I'll just get something in here real quick so you can see that. I do think it's kind of useful to see where your matrices are stored in FCS Express. So you can see now that I have a data file in here, I've had a matrix, the compensation associated with the data file from the time of acquisition. I can go in, I can look at the compensation, I can look at the spillover, and I can see how these things were set up and pulled in. So let me undo out of this and get that removed. And if we want to create a new compensation from a set of single sane controls, essentially what we do is we click on this little button up here, plus button, and you can see that we can actually choose between a compensation and an unmixing, right? So in the past, prior to last week, or if you haven't done your update to the latest version of FCS Express, you wouldn't see unmixing. Again, we're going to come back to that, but I'm going to open up compensations, and this is what we call the compensation and unmixing navigator. So compensation and mixing, they really follow just a few simple rules here. We load our single sane controls. We go through a few steps here where we identify positive and negative populations. And in the end, we come down and we calculate the matrix. So again, you're going to see, even when we go in and do the unmixing, it's going to work very much the same way as performing compensation. So when I go over back to my folder here where I have some data, I actually have a set of single sane controls. You can see here there's a few of them. And then I have something called an all color control where it should be saned with all the colors that I'm working here for my compensation. And what we do to get a compensation set up in FCS Express is we click on this little load button. It says add data for auto compensation. And we're going to navigate to where our data files are stored. So I'm going to kind of go back over here to my compensation. And what I'm going to do is multiple select all of our controls. And in this case, I do have a universal negative. I do have an unstained control. So, if you're using comparing apples to apples, so to say, with all of your samples, you can choose that universal negative. And what FCS Express is going to do is it's going to pull all of your data files into here. It's also going to try to automatically match the parameter name to the control. So what that means is this data file, this is the name of the data file from our computer, and FCS Express is going in and saying, all right, well, that data file has APC in the name, and we know that we're going to try and match that up to the APC parameter. So keep it in mind, it's always a really good idea to annotate your data files as well as possible. If you just put in compensation control 1, well, FCS Express is not going to know what to do with compensation control 1 and what parameter to associate it with. But really at any time, if this auto matching doesn't work so well, or if you didn't annotate, you can always come through, manually select something from the list and get that applied. Now, the other thing that will happen is FCS Express will also look for an unstained control. And if you have an unstained control, it will set that as a negative control, and it knows to do this down here. And again, if it didn't properly identify that, if you called this compensation controlled we might not recognize it as an unstained, but you could come in and select it as a negative control. Now, for all of our data files, all of our single sane controls, we have a column here for selecting the negative control. And if we've set a negative control, we know that all of these should likely use it. Now, you can always come in if you wanted to use a self-negative. So if you have the positive and the negative population within the same data file, you can say use it as a self-negative. Again, it's kind of best, as Kathy mentioned, to compare apples to apples as much as possible. But if you don't have a negative control set up, or if you don't have a universal negative in that data folder, but all of your individual controls have internal negatives, then this will automatically be filled out for you. So, you can see here, this is kind of a perfect case example where we have annotated everything really well. But again, if you need to come in and make some changes, you can do so. So we're going to kind of proceed here through step 2. And essentially what this is going to do is when we create some graphs in FCS Express automatically, we kind of need to know, we probably want to set up some sort of gate on that data. So what we're looking for is where your scatter parameters are. So generally we default here to side scatter A versus forward scatter A, but if you're used to using width and height parameters, you can choose whatever you want. And the next step here is called build histograms. Now this is kind of where things are going to happen very quickly, so keep an eye out on the page tab here at the bottom of FCS Express. When I click build histograms, and it sounds like, do we have a question, Kathy?
Yeah, just one quick question. So one of the participants asked, what happens if a single color is not on the parameter list?
If a single color is not on the parameter list. So if you have a single color control, but it's not here in this list, I assume.
Yes, I believe so.
I don't think that shouldn't be possible, right? If you have if something went wrong, right? Not an FCS Express, but something went wrong. If you labeled something APC, but you do not see an APC parameter in the list, that means that APC, that parameter was not actually collected with the data file. This information in the parameter column is coming directly from the FCS file itself. So if it's not there, it was never collected. But if that kind of thing happens, you can always write us at support@DeNovoSoftware.com. We're kind of happy to help you troubleshoot what's going on, even if it entails like going in and figuring out, all right, how was this data file acquired? Why is something missing? Was it mislabeled? We can always help you out with that sort of thing.
Yeah, and then my second comment that I'll just say very quickly is sometimes the parameter names on the instrument don't actually reflect the fluorochrome. So you might run into a circumstance where that instrument that you're working on might say BB421 and the actual compensation control says JAPI or something like that. So they don't always match up and with the naming, but as long as you're understanding this is the correct detector. Thanks, Sean.
Yeah, no problem. So again, what we're going to do here is click build histograms, and what you're going to see is that in the bottom here in FCS Express and over here, we're going to create a whole bunch of new pages. And these pages are going to be for all of our individual single scene controls, and they're going to create a bunch of stuff here we're going to take a look at. So let me drag this out of the way. And really, this is where we're going to come in and we're going to set up all of our gates and we're going to investigate our positive and negative controls. So you can see here that we have a scatter gate set up for one of our APC stain controls. So we just use essentially whatever the first positive control in the data set is for the first scatter gate. But we also have an unstained in here, and you can see that actually our scatter gate between the two is probably not appropriate, right? If I use this kind of global gating position to move it around here to encompass, what's in our stained control, it's not so great for our negative. So there's always a tool in FCS Express if you need to have gates applied to a specific data file. It's in the gating tab. It's called data specific gate. If you click on this and you move the gate, it will become a data file specific gate. The other kind of nice shortcut is if you hold down the shift key and you move a gate position, you can see that the gate now shifts by itself. It's associated with this particular control and not the stained control. So just keep that in mind. You want to make sure your scatter gates are kind of set up appropriately for all of your controls. And the next process in FCS Express is essentially going through each of our controls and making sure that the positive and the negative populations have been gated and displayed appropriately. So we've done a lot of work between FCS Express 6 and FCS Express 7 to kind of automatically detect where peaks are, also to automatically detect those parameter names when you're loading the data file. So, this is going to work much better in FCS Express 7 than it did in version 6. And you can see actually for the most part here as I'm clicking through and reviewing that we've automatically identified the positive and negatives. And I know for this particular sample, we had a little bit of an issue here with our PE unstained. But again, what you do, you just simply move that marker around, right? So you move the marker around if things don't look exactly correct, and that's where our medians are going to be derived from for calculating compensation. So once we've gone through and reviewed everything, there's just one last step, and that's the calculator matrix. We're not going to really go over these optional steps here today. They're a bit esoteric and not used for probably 99% of what people are doing. You can always contact our team at support to get a little bit more information about that. But what we're going to do is click Calculate Matrices, and you can see that a compensation matrix has been created. So what we have now is we have an entire layout that's devoted to performing our compensation on these controls. This layout, in this case, we have 5 colors, so we have 5 different pages and a scatter plot page. Then we also have a default first page that we have there. So you probably are not going to want to be performing analysis in the same layout where you created compensation. So I always recommend, and this goes for compensation and for unmixing, that when you set one of these up, what we do is we go into the File tab, we do a save or a save as. We'll come over to some location. I'll call this today's comp. And what this will do is save this layout. And if I ever need to come back and revisit this compensation, maybe I need to come in and adjust one of my markers, adjust some of the scatter gates, load in new controls, I can always come back to this layout, and I can always come back to the automatic compensation setup and recalculate the matrix. So it's really useful to be having this layout. But we also have this matrix, right? So the matrix is a little different. It's not, it's part of this layout, but we want to get this associated with another data file or associated with another layout. So what we want to do is save this matrix. And you can see there's a little button up here. It's a little disk icon. And it says save, export the selected compensation. So what I'm going to do is save this. And FCS Express is going to prompt me to save this somewhere. And I'm going to call this today's compensation matrix. And once I have this saved, I can open up a new layout and I can get that applied to other data for actually performing my analysis. So in this case, I can close this out. I can even close out the whole layout, and I can open up FCS Express again and do a new layout, because what I really want to do here is get this applied to a new set of data. So what I'll do is we kind of start the same place where we did, before for creating a compensation. Again, we're doing post-acquisition compensation. So what we want to do is load up a compensation that we've already created. So we click on this little load icon. And you can see that we have the matrix that we created in our other layout, and we can click open. And now that matrix will be available within FCS Express. And you can see this is the matrix that we just set up. And now any data files that we bring into this brand new layout, we can apply this matrix in a number of different ways. So one of the ways that you can get this matrix applied, and kind of coming back to those preferences that I showed you right in the very beginning, is you can say that this matrix is now the default for this layout. Now what that means is if I right click and I say set as default, if I have my preferences set to use the default compensation and then the FCS file, what FCS Express will do is anytime I analyze data in this particular layout of FCS Express, is it will ignore the compensation that came in with the FCS file and automatically use this new compensation default. So I do have my preferences set inversely to that. I still have them set on the default. That's not a problem. What I really want to kind of show you here is what happens. So if I load in my all color control, and you can see here I have this loaded. And what will happen is I have the compensation from the time of acquisition actually applied to this. And you can see I have both compensations here, right? So I could actually move between either of these, which I'll show you in just a minute. But if I change to something like CD8A versus CD95, I can look at the compensation from the time of acquisition. And again, if I had my preferences set inversely where I don't want to use that compensation from the time of acquisition, this default would be automatically applied. So any analysis I do, everything is already compensated. But if I do want to get it applied because I forgot to set that preference, I can simply drag and drop it onto here, and I can see that I have this new compensation that we created post-acquisition applied to this plot now, and any analysis I do in here will now be using that compensation. So dragging and dropping that is one way to get it assigned to a plot or to assign to data. If I grab this other one up here, what I can do is you can see that we have these little buttons here for apply to selected plots, apply to all plots. And again, what this does is when you click that button, you don't have to drag and drop. What it's going to do is just apply that compensation to everything that you happen to have open in this layout. So again, if I move these back and forth, you can see that. The other kind of nice utility that we have with compensation here is, you can see we can load up multiple compensations. And that also means that if I have multiple plots in the software, maybe I'll copy and paste this a few times, get myself zoomed out so I can see what's here, is I can compare different compensations. So if I wanted to say in the top plot, let's look at the compensation from the time of acquisition. On this top left plot, let's look at the compensation that we calculated after the fact. And then maybe on this bottom plot, we want to look at no compensation. And the way that we look at no compensation applied is by double clicking on a plot. And what we're going to do is format that plot. A little formatting dialog popped up over here. And this is all controlled in our overlays. And in our overlays for this plot, if I choose no compensation, you can see this is what that data looks like uncompensated. So again, there's some really great ways in FCS Express to compare different compensations. If you've collected different controls, you've collected controls from one day, you want to see if they're kind of applicable to the next day. Using these tools to move between the compensations is pretty nice and effective. So again, working with the compensations in FCS Express, it's very straightforward. It's all going to work through this compensations navigator. And really the important things to kind of remember is, upfront, if you're going to be working with the compensation from the time of acquisition, you probably want to revisit in your file tab and options, make sure that you're using this default of FCS file and then compensation default. But again, if you're doing post-acquisition compensation most of the time, just change this to compensation default and then FCS file. And what will happen is we're just going to know in FCS Express to use whatever the default is that's set here and kind of move forward with that. So again, that's some of the nitty gritty for, actually getting going with compensation in FCS Express. And I'm going to switch gears here and kind of talk about unmixing. I do just want to pause for a second. Kathy, were there any questions that kind of came through before we kind of move forward to unmixing?
No, there weren't any questions that popped through. I think everything was pretty clear with compensation. One question that I have, and I'm not sure if it's a little bit of a silly question, is sometimes people might have one experiment that they're running with two different tissue types that might have two different sets of compensation, right, with different parameters. Is there a way that we might be able to do that in one compensation window where we have different parameters for each one, right? So maybe one set has 7 colors that are unique, and then the next set has a different seven set of unique colors, or would that be a new workspace?
So I think in that case, you're essentially setting up two different compensation matrices. And what you would probably want to do, I imagine you'd probably have a set of single stain controls for each
Yeah.
one, and some of them would overlap and some of them wouldn't. Essentially, you'd create a layout and you do an automatic compensation for, say, tissue 1, right? Stromal cells or something like that. And then you'd create another compensation and a separate layout for, tissue 2, tumor cells, or whatever it is. And then when you open up a new layout to actually analyze the data, you can pull in multiple compensations. You don't have to work with one created manually. You could have multiple created manually in here. And depending on whatever it is you're working on, maybe you're using the next and previous buttons and using batch processing in the software, things like that. If this just happens to be, what you need for one particular file, load that file up in the data list, load it into everything, click on apply to all plots, and that's going to set it to use that compensation. Now you move to the next data file, or you're comparing side by side. You can grab a few plots, whatever it is, whatever way you want to apply it. You grab whatever that new compensation is. Here I'm just using what came with the data file. You could say apply to selected plots or apply to all. So depending on what you're doing, if you're working with multiple post-acquisition compensations, we do support that. It's not going to be as seamless as if you did it at the time of acquisition, because we just know to load that and what plots to associate it with it,
Yeah.
as we can only have one default. But essentially, that's the way to do it. You can multiple select, you can use next and previous, and just use these little convenient buttons here to get that applied.
Okay, great. Thank you. And I think that's pretty much the question.
Okay,
We're
great.
ready to move
Cool.
on.
Yeah, so let's talk about unmixing. Now, a lot of folks might think, all right, unmixing's probably really hard. I used to think compensation was hard. Oh, unmixing must be so much harder. No, it's not, right? And again, the important thing to remember with any of this data, whether it be compensation or unmixing, is you're only as good as those single sane controls, right? So you got to follow all the rules that Kathy laid out, both for compensation and for unmixing. And as long as you have good single sane controls, everything is easy, right? Whether it be compensation or whether it be unmixing, it's all going to be very straightforward in FCS Express. So what I'm going to do is close out of this layout, and I'm going to open up a new one. And we're going to see really, how similar compensation and unmixing in FCS Express really are. We really just use all of the same tools that we have built in for compensation to do unmixing. It's just except that the kind of math involved is just a little bit different. So when we're ready to set up an unmixing, we choose unmixing. So instead of doing a compensation, we choose an unmixing. And lo and behold, this kind of looks like the same exact dialogue or user interface that we worked through for compensation. And it's going to work the same way. We're going to come in, we're going to select some single sane controls. And in this case, I'm going to go into where my data is stored. I'm going to go into the raw folder, and I'm going to go into the reference group folder where our controls are, and I'm going to grab all of my controls that I want to unmix. So I'm going to click Open File. And again, what FCS Express is going to do is it's going to load up all of this data into the software. It's going to get it loaded into our single sane control section. It's going to try and match up the data file to the correct parameter that you're working with. And it's also going to try to assign it some sort of control, either a sample or a negative control. And it's going to do that, pretty quickly. This is taking longer than loading the compensation data set because these data files are a lot bigger. So, when we're working with some of this data from the Aurora instruments, we get a lot of information associated with them. So again, it takes a little bit of time to load these in here. I don't think that was any sort of crazy amount of time to wait because we don't have to wait after that, right? This is kind of the only hit that we take waiting for our data files to load. But again, what you can see is these are our data files names. We've created a label based off of the data file name. And you can see here I've got all of my controls, and we have our unstained down here. And we know that these are samples, these are negative controls, and that our negative control is coming from our unstained. So the same kind of rules apply here. You can work with a self-negative, you can assign no negative. There's some particular cases for that. For sample types, we can have a sample, we can have a negative control, and unlike compensation, we can have an autofluorescence control in here as well. I'm not going to go over autofluorescence in a lot of detail today. I'm just going to go over, again, some of the practicalities of working with this, but I do encourage you, come out to our webinar on the 29th when we're going to cover, really all the nitty gritty about how to work with autofluorescent controls and how to do some special things with your spectral analysis here. But very simply, if I have everything, loaded in here, things are matched up, I can kind of move on to the next step, which is going to be the same thing as working with compensation. We're going to set up some sort of gate for our scatter parameters so we can get that gated. Again, same kind of thing applies. We have area and width and height parameters. And one of the differences is with spectral data, we'll be able to select which one of the spectral kind of laser lines, or if we want to unmix everything, which generally you're going to be choosing, all of this data, all of the unmixed detectors all at the same time. So again, you may want to come in here, make sure you're choosing, this kind of merged data set for spectral parameters. And the last option, again, is going to be to build histograms. So this is going to happen again pretty quickly. We're going to create it over here on the bottom. We're going to get some different types of plots when we build these histograms. We are going to make use of our spectral plots in FCS Express. And again, this is a kind of another nice and unique feature in FCS Express, is that we have the ability to work with spectral plots directly in the software. But again, everything kind of looks very similar. I have a control here for my scatter gate on some of my cells. I have it over here on my unstained plot. But we're going to go through, and I can kind of get rid of this because I'm going to need a little bit more room working with the spectral data, is that for every single parameter I'm going to unmix, I have a plot showing me the scatter. I have a plot showing me where my positive and negative fraction is being defined. And I actually have a plot showing me the spectrum of that. So what I'm going to do, what I want to do for this CD15 here, I'm going to hold down that shift key. I'm going to move this population around, and you're going to see that this is actually only CD15 positive for this population that's up here, right? So this is a really great use case of, all right, I have to set up a data specific gate. And that's going to automatically identify where the positive population is. You can see that everything's shifted around there with the marker automatically. And then this particular spectrum plot is showing me the events that fall within this particular marker. You'll also see that FCS Express went in and tried to determine where the brightest detector is. So what this is telling us is that in the 388 channel, or 388 detector, that's where we're defining this particular positive from. So again, it's pretty straightforward. We're going to go through, and for every single one of our controls, we're going to try and pick the brightest, try and pick the dimmest. For negatives, we're going to see how our auto fitting, how our peak selection did. And again, for the most part, FCS Express does a pretty good job at figuring these out these days. For some of our controls, we do want to go through, make sure that we're trying to find where our brightest peak is, or what the appropriate population is. And again, with this unmixing data, I've got a lot more parameters, so I got to do a few more pages of work here. But again, we make it pretty straightforward. I kind of come in, find out where that peak is, go through everything here. This is the kind of boring part of doing it, but we'll just adjust our peaks. And then finally, we'll get to our unstained control. For this particular data set, I like to kind of make this a little bit bigger. We'll kind of pick something that's our median between some of these different populations. And if we did have an autofluorescent control, of course we can include that. Again, we'll cover that in a kind of more in-depth webinar later this month. But at this point, I've built my histograms, I've set everything up. I can go back, I can open up this window, and I can click Calculate Matrices. And when I click Calculate Matrices, the unmixing table is going to be created. And you can see, right, that's how quickly we do unmixing in FCS Express, that table populated. We have columns for all of our single scene, for all of our parameters. We have rows for all of our detectors and wavelengths that we've included. And then we're giving the spectral and mixing numbers and information for all of these. So again, just like we did with compensation, we have an entire layout here devoted to unmixing. So what we're going to want to do is come in and do a save as. And I'm going to put this again kind of up here a little bit. And I'm going to call this today's unmixing for webinar. And again, what this will do is if I need to come back, maybe I need to add an autofluorescent control to this. Maybe I need to add another parameter. Maybe I need to kind of go in and use what's here as some sort of unmixing library. You can always come back and reference this layout at any time. But the other thing we'll do is, just like we did with compensation, is we can export that unmixing. And that way we can use it for data files later. And I'm going to call this today's unmixing for our webinar. And this is going to be the unmixing matrix that we can use in FCS Express for any data files going forward. So again, I'm just going to close this out, and we're going to talk about how to get this applied to data files. So let me open up FCS Express again. I'm going to come over here to where our data files are. And let me get FCS Express launched up. So I had closed out of it completely there by accident, but it's launching up on my other screen. So just bear with me here for 30 seconds while it launches up. All right.
Well, while you're waiting for that, Sean, I could just remind people what's really nice when you have that spectral signature plot that pops up is you can use that as a QC tool for yourself, right? So if you want to check your single color controls, that spectrum .scitechbio.com, I believe is the link. I could be wrong, but it's going to be on the slides we send out. Once you pop in whatever fluorochrome it is that, or fluorescent protein it is that you're supposed to be looking at, you can compare it and make sure that that single color is correct, that you didn't swap tubes, that there's no degradation of the dye or anything like that. So this is a really nice opportunity to be able to QC your single colors and make sure that they're appropriate.
Yep, absolutely. So we're launched back up into the software here. And again, just like we did with compensation, we're going to come in and we're going to load up something. So we're going to click that little load icon. And one of the little tricks here, you just got to remember to choose unmixing. We want to load up a .unmixing, not a .compensation. If you leave it as .compensation, you won't actually see it. We're working to make that a little bit more straightforward in the future, but make sure you choose .unmixing. We can load up our unmixing matrix. Again, this loads into the software really quickly. It's just kind of a whole bunch of numbers that are loading into a matrix here. And then I'm viewing the matrix that I created in my other layout. Now, just like with compensation, we can right click here and we can say, set this as the default. Now, what that will do is, there's no kind of unmixing that's associated with a data file like compensation is. The data is either mixed or unmixed, right? So what we do is when we set this as the default, what will happen is if I load up any new data, and we'll do that by coming into here, we'll click Add Data File, and we'll come over to our raw data file folder. We'll go into a sample, we'll load this one up. When we bring this into FCS Express, because that unmixing is set as the default, FCS Express knows that when we insert a plot for this data file, to apply that unmixing to the data file. So when I choose density plot and I click OK, what we're going to see in the title of this plot, it's going to say unmixed or unmixing transformed. And we'll give this a second to pop in, right? So you can see it says unmixing transformed, just like with your other data sets. If you're doing compensation, it would say compensated. And again, what we can do here, we can come in, change the side scatter versus forward scatter. And what we're going to see in this data set, let me get this kind of stuff out of the way since it's not super interesting yet. Create a little gate here, and we'll drag this out, and we can see that these are our unmixed parameters. Now, one way that we know that these are unmixed parameters is because they say ordinary least squares after them. I'll show you this in just a second. We'll bring up CD4 versus CD8. But that little suffix of ordinary least squares, if you don't like that, that's fine. It's just kind of one indication that you're working with an unmixed data set or a data set that was unmixed in FCS Express. This is actually controlled in this little options here. So if I didn't want to view ordinary least squares, or call it my awesome unmixing, because that's going to be publication ready for me, what will happen is when I move to another data file, when I reload this data in here, somehow or another, I think reloading, loading up another data file is the quick way to do this, is if I move to another data file and I switch back to my original data file, that new title that I put in there instead of ordinary least squares is going to be appearing. Now, better yet, you probably don't want it to say ordinary least squares or my awesome unmixing. You can just delete the suffix, and then you don't have to, you'll just see CD8 on the parameter list. So again, once this data is unmixed, it all updates in real time. So as I move these kind of gates around, I mean, this is just working like your standard flow cytometry data. There's nothing kind of, fancy or tricky going on. And of course, you're going to get that live updating gating as you move these populations around. So again, really kind of useful and quick. And I think everybody can see, how fast this is, right? I mean, the only kind of hit that we took in terms of taking some time to do a mixing is loading those data files into FCS Express in the layout that we created for unmixing. That maybe took about like 10 or 15 seconds to load up, 15, 20 data files, whatever it was. And other than that, things pretty much happen in real time. So again, I think the tools in FCS Express are pretty simple to use. Unmixing and compensation, they're just kind of formulas and they're transformations that we apply to the data. Again, I think the important thing to kind of remember is with compensation, about what preferences you're going to be setting up. With unmixing, if you set that unmixing as the default, any data file that you load in or any data files that you kind of load in and move between are going to automatically unuse that. And again, all of this stuff, it's pretty simple to set up, to save, to load it, getting things applied to different plots. If you create different unmixings, and it's one thing I didn't show you here, maybe you create one where you have autofluorescence included, the same thing works. You can load in multiple unmixings. You can apply them to certain plots, apply them to all plots, and you can kind of move back and forth and see how those different unmixings are impacting your data sets and how they're applied. But again, I do want to have a kind of shameless plug for that other webinar that we have coming up, how to perform spectral unmixing in FCS Express 7. Again, in this webinar, we're going to cover things like how to do autofluorescence extraction, how to regate based on some of our spectral plots. We're going to go into some of the nitty-gritty details about kind of troubleshooting and working with unmixing data sets in the software. But I'd like to thank everybody for coming out. I know we'll stop and take some time for a few questions here, but I do appreciate you coming out to learn a little bit more about compensation, learning about unmixing, kind of in a practical use case of, how do I set these things up and get them applied to my data sets in FCS Express. Again, I'd like to thank Kathy and Rui and everybody who came out today for putting this together. And we can stop and take some questions. Kathy, I don't know if anything's come through, but please let me know.
No, that was so awesome. Thank you, Sean. Right now, we don't have any questions, but I'd just like to make a couple of comments while people are thinking of questions, if they do have any. One thing that I'll say that Rui and myself are both very strong proponents of is making sure that you do have the appropriate controls and always taking a look to make sure that from a technical perspective, you're all set. One of the things that people often ask that I see no one ask today, so I just want to address it while we have our audience, is sometimes people ask about making tweaks to compensation or unmixing. So because this is a talk about compensation and unmixing, just wanted to reiterate with everyone while we have you that the best thing to always do is to make sure that you have the appropriate controls and understand why the compensation or unmixing might not look correct to you. There are some statistical ways that you can check it by taking a look at the secondary stain index to see, if your comp or unmixing values are correct. But what we highly, highly discourage is anyone manually tweaking any compensation or unmixing, because when you're taking a look and trying to do that, you could be you're essentially in a way manipulating data, and you can not understand the impact it has on other parameters. So no one did ask that question, but just wanted to use the opportunity to discuss that. And it does look like there's still no questions.
Great. And I take a second just to really reiterate what Kathy said there is, there's really no reason to be compensating things by eye. If you're doing that, it's really the Wild West. You're making your data look like whatever you want it to be. It doesn't represent the true data or what's going on with those cells in a lot of different ways. So, I know people do it. I haven't really heard of a good use case of actually doing it appropriately. But again, if you can just go back and collect good single sane controls, you'll never have to do that, and you'll never have to worry about when it comes time to review your data and your publications about being caught out for how did this population get here and there. Like, you're never doing that by. So again, thanks so much, Kathy, for putting together some of those rules to go over. And I always just like to take the opportunity to reiterate that it's one of those things I see when I go all over the place.
Yeah, no, absolutely. And we want to be part of the good fight for rigor and reproducibility in data with flow included in that. And that's a big part of it. All right, great. I think that's it for today. We will have a recording of this in addition to the slides to send out to everybody. So endless thanks to Sean and to all of our participants, and we'll be sending this out shortly. Stay safe, everybody.